Hello and welcome to this Blender tutorial. My name is Chris. I was going to cover just kind of designing a pedal board. This is for this tutorial. Hopefully you might be able to find use in terms of like if you're new to designing in Blender, especially for like 3D printing environment or you're using it for any sort of real-world design mock-up type use. It as an alternative to like a CAD, some of the other CAD type software out there. Blender is a nice open source free modeling tool, and I'm actually pretty familiar with it in terms of modeling work. So I'll go ahead and get started here. The first thing that when I'm designing like for some sort of real world application, I always want to set up like my file, and I'm working from the default Blender file, like as you're starting up the program with the kind of standard user default preferences with the default cube that I've actually deleted in this case. You'll want to go ahead and set up like your units. Now, I did have in mind like inches. I was working in inches and feet for the scaling of the unit relationship of the design that I had in mind. But for ease in converting units, say from like millimeters to centimeters, or in this case with imperial units working from inches to feet, the metric system is actually a little bit easier to work with in design. So I actually convert from imperial to metric and then convert back from metric to imperial, once I'm done, to get those scalings set up if I need it that way. At least I kind of have a sense, because I have a lot of familiarity because I'm American and we use imperial over here quite a bit. I have kind of a scaling sense in mind, with the foot relative to a meter that, I'm not as familiar with, like in terms of scaling relationships. So, but in terms of converting units, I do recommend, working in metric. Blender doesn't make it easy going from, and the part of the problem with Blender is that when you're going from feet, you'll have it in a fraction of a foot, which is not in base 10. It's not a base 10 conversion. It's actually a base 12 conversion, which makes it kind of confusing. So, when you're working with metric, it's a lot easier going from centimeters to meters, going from centimeters to millimeters, and so forth. So, in this case, you also want to have like the design, the amount of like your design in mind with the overall kind of dimensions that you're working with. So in this case, I'm working with a board that's like 12.5 inches wide, which is 31.75 centimeters. I have this convenient Google conversion pulled up, inches to centimeters on the search will pull up the tool, the conversion tool. That makes it convenient, easy, quick, and free. So 31.75 centimeters. So what I'll go ahead and do is, and I've already set up the metric system and the scaling at 0.075. You can add, like in this case, to verify, I'm working with the plane here in the default view, and I'll go ahead and zoom in on it with the period, pressing the period button, and I'll go ahead and highlight an edge so that we can also verify the length of that edge. And so you'll just pull up under the properties, like the edge length, and by default we have 29.308 centimeters, which is approximately in range for that scaling. When we're good to go on the when you have that established, you know, for a given object that you're adding by default, we can go ahead and get started. Now, the one thing I was going to say is that while I could subdivide this, I'm going to avoid that because I found out earlier I had forgotten the sequence in which I was kind of building this pedal board, and so I kind of got myself stalled out because of sequence and designing. So like I have in mind for the design, the dimensions, overall dimensions, and then like the switches that are going to be applied, you know, to the board that I need to have like placed. So when you're designing this, I kind of recommend, like, if you're working with like inclines and slopes and everything else, I recommend working kind of rough before you actually subdivide in the context of the switch. And I'll explain it as I'm kind of going through, explain why the sequence is kind of important in construction, design, work. It's not that there isn't a work around and taking a different sequence, but it becomes kind of a little bit more convoluted, complicated, and you might lose a little bit of control taking an alternate route, or you have to find a workaround at least for it. So let's see, I'm going to go ahead and scale this out to increase it, and I use the number pad to kind of get the dimensions exactly refined the way I need it. So let's see, 1.4, 1.2. I usually, what I'll do is type in a number and look for so 1.1, 0.05, 31, 30. Okay, so 7, 8, 7. Three. Okay, yep. So there we have 31.75. I usually use my numeric pad when scaling, like I hit SY, and then I use the number pad to type in the exact scaling so that I could get my edge length exactly the way that I need it on that particular axis. We're going to scale on the x-axis for 5-inch lengthwise, so we need 12.7 centimeters. So we'll go back here, and we know we need to scale it down. Oops. So we need to select both there. Actually, I'll just do that, and we go 0.4. Oops. Somehow, I don't know if this is square. I don't think it is. Yeah, because I had one edge selected. My apologies on that. So I have to go back, scale this. So it's 1.04. Oh, and that's the reason why I had this in edit mode. So I could see this. 1.05, 7, 8, 9, 8. So 31.75, 8, 3, 3, 3. There we go. Let's scale. Oops, Y, 0.4, what did I say? Let me go back. 12.7 inch, or 12.7 centimeters. So scale Y, 0.5, 0.4, 333. Yep. Okay, so we have 12.7 centimeters, 31.75 centimeters, which is width of the pedal board. So we're working with the plane right now, and I can kind of toggle this, so this is just completely flat. So what we'll want to do is actually extrude this up on the Z, and I think I had stated earlier that I wanted this approximately 1.5 inches for the riser, the first step riser. I'm going to have like a 2-step riser system, so 1.5 inches, 3.81 centimeters up. So we'll extrude, hit Z, and well, we can see the incline in terms of like the number of centimeters, although it's kind of obscured here. And 2.758, and so we want to go 0.4. That's too high. Well, no, actually 0.5. Hit Control Z. If you forget your number, whenever you hit the extrude button, always hit Control Z to undo the extra vertices that you've added in the process. If you forget to undo that, then you'll have like all these vertices compounded on top of one another that are lingering around. So 3.81 I think is, so 5.5, 4, 0.5, 2, 0, 1, 2, 3. 4, 5, 9, 4. It's kind of a, oops. 7, 9. We wanted 3.81. I usually get this stuff exact, but for some reason we don't want to hit that. Well, this is odd. It doesn't want to increase. Now we'll get it approximate 3.79 centimeters. Sounds good. We're just off by, it's like 0.02 centimeters. So it's very, very small difference. So we'll just go with that. Yeah, 3.7879 sounds good for the first step riser. So the next thing we want to do is lift this back edge to give it a little bit of slope on the first riser. So, and this is kind of important that I didn't subdivide for all the given switch cells this foot pedal board, because now I can kind of more conveniently and easily with this sequence process and design just create the slope and the step. And so to do this, we'll just and we want to create like a 6-degree slope, something like 6 degrees. If you know the exact angle that you're looking for, you're just kind of wanting a rough guide as to like what the rise would be. We can multiply. We know that it's like 5 inches wide. You know, for the, it's like, if you know a little bit of, all you have to know, like, well, one thing in trig that, if you remember, is with like the tangent of the angle, you have rise over run. So if the run is like 5 inches tangent and you wanted a slope of 6 degrees, you just multiply tangent of the angle, desired angle, 6 degrees, times 5 inches, which would be like 0.52552,176 inches. So we can copy that and then just paste it in our conversion utility, and then we have a 1.3348 centimeter rise for the slope. So we'll just go ahead and translate this back edge. So we just need to go up by 1 point, what did I say? 1.3348. Doesn't have to be perfect. If you don't like the angle, then you can kind of reduce it or increase it as necessary. So 1.33. I just kind of get it in an approximate region. I'm not doing it perfectly, you know, at a 6 degree angle. But that looks good. I kind of like that slope, you know, for the first step riser. So at this point, I do know that, like, in the design of the board, I had it in mind that I wanted, and I'm just going to change this to an orthographic view so that everything looks nice and kind of box rectangular without perspective view there. But in any event, I did have it in mind that I was going to have something like 10 switches, and I wanted like 2 rows with like 5 columns, and dividing, kind of subdividing, you know, this given spatial area for the kind of the switchboard of the pedal board design. So what we'd want to go ahead and do is the next in sequence is go ahead and kind of create our rows. We need 2 rows, so I'll just go ahead and loop cut on this side. If you hit the loop cut button and then toggle on the side of the kind of the board, and then I hit the right mouse button to kind of complete the loop cut where it's evenly divided on this. And so if I'm rotating by holding the middle mouse button, we can see that it's kind of an even row-to-row subdivision there of the board. So the next thing we'll want to do is go ahead and create the step rise on this, and I'm going to go ahead and actually extrude like half of this board to do that. So to extrude it, we'll need to grab these 2 sets of pixels here, and we'll just go up, and so we might have something in similar, you know, for the next step rise. I'm going to constrain this to the global Z for the axis, and we'll go up approximately the same amount, like 1 point. Maybe a little bit. No, that's about, yeah, that's about good. We'll do about 1 point. And you just kind of visually looking at this, kind of get an idea. So it looks like in relation to the other step, we'll probably create a little extra slope on this next step, kind of balance things out kind of visually. But so I'm thinking something like around 2 centimeters looks good. So we can kind of verify what we have already for the edge length by just grabbing and holding the shift button down. We can add the number of centimeters that we already have existing. So it's like 1.99 plus 5.129 centimeters. We can add that up and kind of see what we're looking at for that back plate already. So 1.99 plus 5.129 gives us 7.119 centimeters. And then we can enter that in. That's about 2.8 inches. That's not bad. I was looking for probably no more than 3 to 4 inches for the height of the back plate. So we still have a little bit of wiggle room in adjusting the plate for the next step riser up if we need to, which I did kind of want to do. I wanted to kind of adjust that, give it a little more dimension there, and maybe actually lower the edge on the other part of the riser. So we'll go ahead and hit G and then Z again, kind of lift the slope a little bit to our liking. So yeah, that looks kind of good like that. And maybe bring down the other slope. So yeah, it looks like we have a nice kind of contrast between the two. And actually maybe bring the slope down on the other just slightly, so it's a little less imbalanced between the two. Maybe lift this just a tad. Yeah, I kind of like that. Let's switch out of and get into perspective view to kind of get an idea of what kind of that real world kind of look idea. Okay, so I kind of like what I'm seeing here in terms of like the design overall. So the next thing we want to go ahead and do is we'll go ahead and kind of subdivide these cells. Now, the one thing I haven't done, like in my modeling, that you would probably, when you get into this more extensively, is that you'll want to account for the plywood or whatever media that you're working with, like the length of it. Just like if you're like modeling a house and architecture, you might be accounting for like the width of the walls that you're working with, exterior walls, interior walls. You're going to have the same thing with in practice and 3D print design. You have to account for the wall thickness when you're design modeling. So I'm kind of neglecting that at this point. I might actually cover that in kind of a continuum of this kind of design work to kind of show the process of how I do that. It's a little more kind of tedious work. I believe at the outset, though, what I ended up doing was working on the single plane and then establishing the width of the plywood along all sides of the plane that I was working with before I actually extruded it, and extruded everything up as I needed it, but also having everything already kind of set up and loop cuts so that I can make easier work and deciding what the how I was going to have one wall going into another, with the given, like I said, plywood that I was working with. So what I'll go ahead and do though is just to kind of complete this tutorial here is set up the cells, and then I'll which we'll do by loop cutting on this one axis. I run the mouse cursor up to here, hit the loop, and then roll the mouse button. We need a total of 1, 2, 3, 4. 1, 2, 3, 4, 5. So we have 5 cells, 5 columns on the pedal board, and we'll hit the whoops. I was supposed to go through, but it didn't. Oh, I know why. I need to hit the left mouse button, then right mouse button to complete it, and that gives us conveniently the 5 cells, 5 columns that we need, and then so that each of these are representing, you know, the cell for the foot switch. So the next thing I'll cover is just adding the holes, necessary holes, and that's given to specific metrics. Like in one case, I know that my foot pedal switch is working at like 9.75 or 0.9755 millimeters. Or I should say, I apologize, 9.755 millimeters, which is not 0.9755 centimeters. You can actually work in Blender in millimeters. So we're going to add, and I won't cover the process of adding like another hole for an LED light, but you can apply the same process if you wanted to create additional holes. Like in each given cell unit, switch cell unit, you just need to select, you know, a given location and use the same kind of procedure that I'm using here and designing, like the where the switch holes are going to go when you're kind of creating your blueprint template. But in any event, to kind of start this process, what I'll go ahead and do is select each cell face for each switch, and I'll show the process of creating a single cell hole. I'm not going to cover it through each because it's just kind of repetitive. It's the exact same procedure done over and over. I'll actually cover just adding 2 switches on each row. The procedure, it's very simple. But what we'll need to do, and this kind of give you some experience in cutting a hole in your existing mesh, how to do that, and create it to the hole where you need it. In this case, I'm working with simple hole for the geometry that I need to cut into the mesh. I just need a circle since the switch is circular. So in order to do this, first we need to kind of snap our cursor to the selected. And what's nice about snapping the cursor to selected is that it snaps it centered to the cell, which corresponds exactly to the position of the switch hole that I need. So again, it's just once we select the face, we go to face mode and edit mode, or face select and edit mode, and then snap to cursor. The next thing that we need to do is we need to have our properties tab open over to the right as shown here, and we'll pull the transform orientation box or tab up, and it's stating global, which corresponds to the transform orientation here. So we'll go ahead and need to actually record the normal transform orientation data, and then we'll need the switch tool, that thing open. So we'll hit the plus button under transform orientation in the property view, and this will give us a create orientation dialog over to the left under the tool shelf. I usually type in something like A or whatever conveniently that works and toggle these two check boxes. And so that transform orientation is recorded. We can see that just by hitting this under the Use 3D Manipulator widget for controlling transforms. You can toggle it to view it to verify that the transform is there. You don't need to have it toggled visible necessarily. In fact, I usually disable it, the visibility of that, since it kind of obscures my measure of the length edges and all that other information or data. So, but you can toggle that on to verify it. I'll leave it on for now. Actually, I'm going to turn it off again. The next thing we do is I'll just go ahead and deselect the object, get out of edit mode, just select a camera, for instance, and then we'll go ahead and add a curve, the circle. Now the interesting thing is once the circle comes up, we can input the radius, and we'll need to go ahead and do that. Now we know that we need 9.755 according to the specs of the switch, millimeters, so I can type in 9.755 mm and then hit enter, and lo and behold, it populates a circle that's exactly that diameter. And I apologize. You want to pay attention to this. If you order any sort of switch, they may be giving you the diameter as opposed to the radius and the measure. So you want to verify, check and verify. So actually, if it's 9.755 millimeters in diameter, we would need to divide that by 2 to get the radius. So it's 4.87575. Just record that, 4.8775 millimeters. So I'll just go ahead and enter that. That looks a little more reasonable. The switch is not going to be that big in any event, but 4.7877 millimeters may be good before you actually design to get your switches and then actually take some sort of measuring ruler and measure the exact diameter, because sometimes what they list for specs on some of these components, they're not quite the what they're listed. That happens typically with plywood all the time, that you'll get some sort of variance or tolerance for variance. But in any event, we'll go with 4.877 millimeters. We'll need to transform the circle because we'll notice that it's kind of flat relative to the existing plane that we're trying to match it to. So the next thing is I'm going to go ahead and toggle this 2D. I don't know if I technically need to do it, but I'm going to go ahead and change this to none and make sure there's no fill on it. So you'll have to repeat that or just keep it in 3D, either way. And then I don't think you have to worry about the fill and all that jazz. But if you do go to 2D, make sure you disable the fill and make sure, that there's no fill on it. So the next thing we do is we transform the object so that it matches the plane. And also we'll want to make sure to snap snap the object selection to cursor. So it's already, usually it'll populate to where the cursor's already there, so that might be a redundant step that's unnecessary. But the one thing that you do need to do is go to Object, Transform, and then Align Transform Orientation. So now we see that the circle that we want to apply is matched to the plane, and it's applied on the surface of that cell, at that plane, at that exact position. So once that is done, what we'll need to do is go ahead and convert this circle, it's a Bezier object, convert it. So Alt-C, hit and select a mesh to convert it. And then we'll hold the Shift button down and right-click on the pedal board object, and then hit Control J, and that couples the curve mesh with the object mesh. And then we'll go back to edit mode, and we're going to delete the face. So just hit the delete key and choose face, and we'll see just a circle that's shown there. And the next thing we do is we'll want to, I could just go to edge select, hit C, and we'll disable the length, edge length. We got all sorts of data populating there. And so when I hit the C button and left mouse button click on the circle, I've highlighted that. Now we'll want to select the edges of the face that we just deleted. And so just go around while holding the shift button, right mouse button click on each of these edges surrounding that, and then hit Alt F. And lo and behold, we have our circle populated, and we have the whole cut out there. So that is just going to be repeated stepwise, sequentially across the board. Now, if you wanted to center the switch in some arbitrary way, but perhaps more complicated way relative to the snapping procedure, you'll probably have to develop some sort of method for doing that. You can work, for instance, on subdividing. One possible way to do that is to subdivide the existing cell that you're working in and refining it until you get to a snap point that you can snap to that positions your snap cursor the way that you need it, and then just delete all the faces and put the once you have put the circle or snapped the given hole where you need it, and just delete all those faces and then just select the original edge. Now you may have to do stepwise a lot more work to reposition it. There may be even easier ways to do it than the way that I just described it there. I was just kind of thinking off the top of my head. But if you wanted to, for instance, put like a little LED light, you could center it, and I'll show a snap mark right there. Like I have it centered on that particular face, just above the switch itself, which seems like it's probably a good position there. Or you may be able to change the snap marker, where it's a little bit less on a little bit closer to the switch on that given face, by adjusting the snap position. But that actually maybe like that's where I've put my LED light when I've done that. So in any event, I think I'm going to go ahead and skip, because this has already been a pretty long tutorial. I'm going to go ahead and skip adding the holes, but you'll just repeat the procedure that I described earlier for each cell. Just again selecting the cell, snapping the cursor to the center of the cell, which is snap, go to mesh, snap, cursor to selected. And once you've done that, you'll need to set up a transform orientation, record that. Actually, you don't need to record as long as your orientation for each cell is the same for the normals of the plane. Where you'll need to record it is if you go like where on the step riser I have a different angle here for the normal, so you'll need to re-record the transform orientation. So you can click on the X, for instance, when you're there, go to normal, hit plus, and it populates, records the normal data for that next cell. So you'll need to do that when you go to like on a step riser system, or where you've got different angles, planar angles with different normal axis coordinates values, you'll need to record the transform orientation to get any sort of geometry to conform to that. But in any event, that's how it's basically, that's how it's done for this pedal board design. So I've kind of covered the basics and kind of like design work that I wanted to cover for this tutorial. Wanted to thank you again for listening in, and you have a great day there.